Hi students, welcome to week 3 of CYBR 306. This week we are going to be talking about network security, and if you've already taken systems and security, you probably know a lot about this, so this might be a lot of review for you. I know I teach 203, so we've definitely covered a lot of this stuff. But yeah, so we're going to do some review on networking, some little discussion, um, and then we're going to talk about Nmap, and you'll be working with Nmap in your assignment for this week. Also, we'll talk about some things that have been happening in the news related to this content. And so yeah, so I do have links to some videos that I want you to watch this week. They're all on the slides. And the first one is DHCP, and that stands for Dynamic Host Configuration Protocol. And this automatically assigns IP addresses and other network configuration parameters to devices on a network. So basically, when a smartphone connects to a Wi-Fi network, the DHCP assigns it an IP address without any manual configuration. So yeah, it just allows devices to communicate on an IP-based network by assigning unique IP addresses and other network configuration parameters dynamically. Also provides other network settings like subnet mask and default gateway and other things. Why do we need it? It's efficient because it automatically assigns and manages IP addresses. So watch this video, just gives you a little more in-depth information. So for networking, we're going to be going over some of these concepts. So the OSI model, data flow, and TCP IP. All right, so OSI is Open Systems Interconnection, and this is a model. It's a layered network model that standardizes communication functions, and it's often used as a reference point. Excuse me. I'll give you a couple tips on how to memorize the layers. So one way you could say, all people seem to need data processing. So take the first letter of each of the layers, and that's how that goes. You can also say, start from the bottom and say, please do not throw sausage pizza away. So that's another way to kind of remember. But yeah, so on these layers, data segments, packets, frames, and bits are all associated with these layers. And layer 1 is the physical layer, which includes media wires, fiber, radio waves. So it provides binary transmissions into ones and zeros. Layer 2 is the data link layer, and it transports data between two nodes. The MAC, which is the unique identifier on the device. The LLC logic link control is for error detection and provides physical addressing. And then layer 3 is the network layer, and this helps empower determination and IP logic addressing. Layer 4 of the OSI model is the transport layer, right? So it's responsible for end-to-end data delivery between applications. And the connection-oriented protocols, we have the transmission control protocol, which is TCP, that provides reliable, ordered, and error-checked delivery of data. It's commonly used for applications that require high reliability, such as HTTP, which is web browsing, FTP, which is file transfer, and email. Yeah, so all this stuff occurs in this layer, all this, transport stuff. The layer 5 is the session layer, and that's responsible for establishing, managing, and terminating communication sessions between applications, right? So that's the session layer. And it basically just provides the framework for a logical connection between two communicating applications. And this just ensures that data is exchanged in a reliable and synchronized manner. Next, we have layer 6, which is presentation. And this layer is responsible for the syntax and semantics of data. So it acts as a translator between different data formats, and it just ensures that data is presented in a way that the application can understand. So some examples of the protocols and functions at layer 6. The ASCII, which is the American Standard Code for Information Interchange, which is just a character encoding standard. JPEG, which stands for Joint Photographic Experts Group, which is a standard for compressing images, which we all know. GIF, we know what that is. That stands for Graphics Interchange Format. PNG, PNG, whatever. Portable network graphics, that's just a lossless image compression format. So basically it deals with like data compression, data encryption, data decryption, data formatting, all that kind of stuff is happening here in the presentation layer, which basically just ensures that data is presented in a way that is both understandable and secure. Two things. Then we have layer 7, which is the application layer. And it's the topmost layer of this OSI model. It's the layer closest to the end user and deals with applications that directly interact with the user. And it presents data to users, applications, and websites. So that's the OSI model. If we're applying the OSI model to speech communication, even though the OSI model was primarily designed for digital networks, it can be adapted to understand the communication process involved in speech, right? So here's a breakdown of how each layer might relate. So if we look at layer 1, that would be the physical layer function. Again, this deals with the physical transmission of data. So if we were looking at speech, this would be the production of sound waves by the vocal cords, right? So, for example, that vibration of the vocal cords produces sound waves that are transmitted through the air. And then, in keeping with this example, the data link layer function. So this layer handles framing and error detection. So in speech, this could be the intonation, the pitch, and the rhythm that convey emotion and meaning. So, for example, using rising intonation for questions or falling intonation for statements. For layer 3, the network layer, again, this layer handles routing and addressing. In speech, this might be the choice of words or phrases to convey whatever you wanted to convey, like in your intended meaning. So, for example, selecting appropriate vocabulary to express complex ideas. And then layer 4, that's the transport layer function, which ensures reliable data transmission. So in the speech example, this could be the vocal volume and the clarity to ensure that the message is understood. So for example, speaking loudly and clearly if you're in a very noisy environment, just because you want to make sure that your message is heard. And then layer 5, the session layer, this is the layer that establishes, manages, and terminates sessions. So in speech, this might be the initiation and termination of a conversation, right? So like a greeting or a farewell. So, you know, for example, a conversation usually starts with a greeting, like hello, hi, and then when you're done, it usually ends with a farewell, like okay, thank you, bye, that sort of thing. Layer 6 would be the presentation layer, which ensures that data is in a suitable format for the application. So in speech, this could be vocal apparatus and the tongue shaping, that tongue that shapes your sounds. So, you know, how your tongue positions itself to produce different vowels and consonants. Layer 7, which is the final layer, the application layer. This layer handles the specific application or service. So in speech communication, this would be the brain or cognitive processes that interpret and formulate the message to be conveyed. So, for example, the brain processes thoughts and emotions, and then uses that to create a coherent message. So that's kind of a good example to help you kind of understand the context. We could also apply this to like letter communication. Layer 3, the network layer, that could be like the postal service, which determines which route the letter will take. The data is the envelope with the letter, which includes the recipient's address. The transport layer, that would be the postal service ensuring that the letter is delivered reliably and in the correct order. And then the data would be the envelope with the letter. 5, the session layer, the sender establishes a connection with the postal service, and then the data, that would be the letter, is placed in an envelope with the recipient's address. Layer 6, the presentation layer, so the data is formatted with a specific layout, font, and style, and also the language of the letter. And then finally, the application layer, that would be the sender's brain. So the data is the content of the letters or the words or ideas and the thoughts that the sender is expressing. All right, so both the OSI model and the TCP IP model are frameworks used to understand and describe network communication. But they do differ in structure, focus, and real-world application. So TCP IP model, the purpose is it's a practical model based on the protocols used on the internet. 4 layers, it's got application, transport, intranet, and network access. And the focus, it describes the actual protocols and their interactions in network communication. For real-world application, it's widely used in networking and internet technologies. The OSI model is a conceptual framework designed to standardize communication protocols across different systems. So it's got more layers, it's got the physical data link, the data link, the network, transport, session, presentation, application, right? We just went through all that. But the focus provides a theoretical foundation for understanding network communication. And the real-world applications primarily used as a teaching tool and for understanding network concepts. So here are some key differences between these two models. While both models provide valuable insights into network communication, the OSI offers a theoretical foundation. The TCP IP model reflects the practical implementation of network protocols. And the TCP IP model has become the de facto standard for internet communication. So here's a YouTube video that I would like you to watch. It's not long, but this is just going to explain the difference between the IP version 4 and the IP version 6. And these are the 2 primary protocols that are used for addressing devices on the internet. Both serve the same fundamental purpose, but they differ in terms of addressing space and structure. So take a look at this video. It goes into a little bit more. It's very informative. But I will say that IP version 4 has been the dominant protocol for many years, but IPv6 is becoming increasingly important to address the growing demand for internet connectivity. It's got larger addressing space, and there's other advantages that make it a promising solution for the future of the internet. So take a look at the video. All right, so in the news, February 2026, the Singapore Telecom espionage campaign. This is a real attack that happened just a few months ago, and it ties directly into what we've been studying. So in February 2026, Singapore's cybersecurity agency went public with something that had been unfolding for nearly a year. It was a sophisticated espionage operation and then quietly compromised every single major telecommunications provider in the country. So who did it? The threat actors tracked as UNC 3886, which is a China-linked advanced persistent threat group. The advanced persistent part is very key here. This wasn't a smash and grab job. These attackers got in quietly, stayed hidden for months, and systematically worked through the network. That's the hallmark of a nation state level actor. Their goal wasn't financial, it was intelligence gathering. How did they do it? So let's talk about their technique. Because this connects directly to our OSI model discussion, the attackers used two primary tools: zero-day exploits, so vulnerabilities that were unknown to the software vendors at the time, no patch existed or exists. The defenders have no warning, and this is why threat intelligence and network monitoring are so critical. If you can't patch it, you need to detect anomalous behavior at the network layer. Also, rootkits, and we talked about this in 203, is malware that embeds itself deep into the operating system, often at the kernel level, and a rootkit can hide files, processes, and network connections from the admin. So this is why we talk about defense in depth. There's no single control that can catch everything. So here's what makes this especially alarming. They didn't hit one provider, they hit all four. So telecom infrastructure carries voice, internet, government, and government communications. So compromising it gives an adversary the ability to intercept traffic, monitor communications, or potentially disrupt service for an entire nation. And that's why we classify telecom as critical infrastructure. The response. So Singapore's response was massive. They launched Operation Cyber Guardian, which was described as their largest cybersecurity counter operation ever. It was an 11-month effort to detect the full extent of the intrusion, evict the attackers, and harden their networks. And this illustrates something important. Incident response isn't fast. Cleanup can take far longer than the attack itself. Just as something to think about, if you were the CISO of one of these telecom companies, which layer of the OSI model would you prioritize monitoring for signs of a rootkit or an APT intrusion, and why? So think about that. That may come up in a discussion. And yeah, so connections to this. So looking at defense in depth, the OSI models, so layer 1 through 3. The CV zero-day concepts, and it is relevant to Nmap. So you will be working with Nmap on your assignment for this week as well. But yeah, so that happened. We also wanted to bring up another attack. This is the UMMC ransomware attack, which also happened in February 2026, the University of Mississippi Medical Center. And so this hits very close to home for anyone who thinks about healthcare security. So in February 2026, a ransomware attack struck the University of Mississippi Medical Center, and the consequences weren't just technical. They were immediately life-affecting. So everyone in their 35 clinic locations across the entire state of Mississippi was forced to close. Scheduled surgeries were canceled. Staff went back to writing on paper. So yeah, we know what ransomware is, right? What does it do? Because it's a network security issue at its core, ransomware is a malware that spreads across a network, finds data and systems it can reach, and encrypts them, making them completely inaccessible. The attacker then demands a ransom payment, usually in crypto, in exchange for the description key. So the key word here is spreads. This isn't just a virus that hits one machine. It moves laterally across the network, exploiting weak segmentation, um, shared credentials, and overly permissive network access. And this is exactly why we study network architecture. So how you design your network determines how far an attacker can get in. So how did it take down the hospital? So UMMC runs Epic, which is one of the most widely used electronic medical record systems in the country. So when ransomware encrypted their network, Epic went down. And that means doctors couldn't access patient records, nurses couldn't see medication orders, lab results couldn't be transmitted electronically, scheduling systems were offline. So yeah, if you think about it from an OSI model perspective, the application layer where Epic lives was destroyed. Um, but how did the attack get there? It traveled through the network layers below it, and this is why securing layers 1 through 4, your physical network, your data links, your routing, your transport, is foundational to protecting the applications that are above. Staff had to go back to pen and paper in a modern hospital. That's just not just inconvenient. It introduces risks of medication errors, missed allergies, delayed diagnosis. Um, and healthcare is one of the most attacked sectors in cybersecurity. It's not just random attack. They attack hospitals because the data is extremely valuable, the medical records. Hospitals cannot afford downtime, so there's a lot of pressure to pay a ransom, right? Many healthcare systems run on these old legacy systems with outdated software that hasn't been patched, so they're very vulnerable. And this is a calculated business decisions that criminal organizations make. So yeah, so what could have been done? This is where your assignment on defense in depth comes directly into play. So network segmentation, backups, endpoint detection, least privilege, all of these things are important for that. So just another example of why what we do is so important. All right, so not much more on this. So the DNS, the domain name system, it's just like a phone book for the internet. It translates human readable domain names into machine readable IP addresses. So when you type a website address into your browser, yeah, that's where the DNS kind of comes in. So for more on that, you can watch that video. And I just wanted to go on over what is happening upcoming. So you have your reading for this week, your discussion, and also your assignment for this week. And there will be posting 2 demo videos for Nmap because you'll be working with Nmap this week. And they will be those videos, one for Windows and one for Mac, depending on what you have. So yeah, so you're going to be using that to answer your questions on your assignment. You can work with each other. I know this is online, but you can work with each other. That's perfectly fine with me. But just make sure your results are submitted separately. You can use the questions board for technical issues, or email me as well if you get stuck. But yeah, so that's what's happening, and that's it for this week. So yeah, email me if you have any questions, and do use the question board and do work with each other on this. But this will be the first week that you're really doing some hands-on stuff, and yeah, I'm excited about it. All right, so let's get to it.